Okay, so 5.5, solving rational inequalities. So we are given 5 over x minus 2 less than or equal to 1. Okay, so we cannot solve rational inequalities like rational equations. It is quite different. Okay, so this is the reason, because when you're solving the equations, so you're getting the LCM and multiplying both sides by the LCM. If you do the same thing with rational inequalities, let's remember this direction of the inequality changes if you multiply or divide both sides by a negative number. And when you, let's say, multiply both sides by x minus 2 is sometimes positive, sometimes negative, right? So based on that, you don't know if you need to change this direction of the inequality. That is the reason we cannot solve it like rational equations. What are we going to do? We're going to collect everything on one side and makes one side equal to 0. Okay, so that is the first step. So we get 5 over x minus 2 minus 1 less than or equal to 0. Then we are going to have a common denominator and collect, right? Do the subtraction. So x minus 2, we are going to multiply 1 by that. So 5 over x minus 2 minus x minus 2 over x minus 2. So you are just having a common denominator. Okay. Now collect. So 5 minus x minus 2 over x minus 2. So you can skip this step, okay, and go there directly. So you get 5 minus x plus 2 gives you negative x plus 7 over x minus 2. Now we want to know, the sign of negative x plus 7 over x minus 2, so that we can decide where it is negative and where it is positive, right? Because we want it to be negative. We want this rational expression to be less than 0, or less than or equal to 0. We want it to be negative or 0. So how are we going to do that? We're going to do this factor table, okay? So the first thing, I want to factor this negative sign, because usually, if you have a negative sign in front of the leading term, then it kind of may create some problems later on. It might be a little bit more difficult. Therefore, I'm going to factor that negative sign. So you get negative x minus 7 over x minus 2 less than or equal to 0. Then we are going to make the factor table. When you do the factor table, as you know, you put the factors on the left. So we did this with polynomial inequalities. So what did we do? We took all the factors, right, and put them on the left, and on the top we put the zeros of that polynomial. In this case, we have a rational expression, so we're going to take the zeros of the numerator and denominator. Okay, so in this case, what is the 0 of numerator? 7. Denominator? 2. So you take both of them and put them in order from smallest to largest. So we have 2 and 7. The factors. So negative sign, x minus 7 and x minus 2. Okay, so negative sign is negative at all times. So x minus 7 is negative before 7, positive after. So x minus 2 is 0 at 2, negative before and positive after. Okay. So now, how do you get? So you multiply all those signs to get the final solution, right? So negative times negative times negative gives you negative. Negative times positive gives you positive, and this is negative. So again, what do we need? We need this expression, this rational expression, less than 0. We want it to be negative or 0. So negative is here. So now write the notation for this, right? Intervals for this. So negative infinity to negative 2, 7 to positive infinity. Now decide what kind of brackets that you need to use here, right? So because it says less than or equal to, you kind of want to use the square bracket, correct? But now you need to be careful.
Should be positive
Oh, so you are correct. Thank you. It is positive 2. Okay. Now you want to check the restrictions. Okay. So what is the restriction? 2. So actually, you know, I was supposed to take that 2 because it is less than or equal to 0, correct? But now, because 2 is a restriction, so you should not be taking it. So it is a round bracket. How about 7? So again, you want to use a square bracket. And yes, 7 is not a restriction, right? And it can be less than or equal to 0, and 7 makes it 0, which is fine. So that 7 can be taken. That should be your final solution. So let's look at the second one. So we have 4 over x plus 3 less than or equal to 2 over x plus 1. Again, so what are we going to do? Collect everything on one side, make one side equal to 0. Second, have a common denominator. Again, you need to use LCM. So the LCM is x plus 3 times x plus 1, right? So have a common denominator. So multiply the first expression by x plus 1, second one by x plus 3. So you get 4 times x plus 1 minus 2 times x plus 3, and the common denominator is x plus 3 times x plus 1. Now expand the brackets. So you get 4x plus 4 minus 2x minus 6 over x plus 3, x plus 1. So collect. So you get 2x minus 2 over x plus 3 times x plus 1. So factor 2, you get 2 times x minus 1 over x plus 3, x plus 1. Again, so we want this rational expression. It says less than or equal to 0, so we want it negative or 0. Okay. Again, we're going to do the factor table. So now look at the zeros of numerator and denominator. So you have 1 from the numerator, you have negative 3 and negative 1 from the denominator. Put them in order from smallest to largest. So negative 3, negative 1, positive 1. So on the left, put the factors. Okay. So there is 2. 2 is a positive number. And actually, if you multiply any number by a positive number, you don't change the sign of it, right? Let's say you multiply negative 3 by 2 or 5 by 2. So the sign of the number does not change if you multiply it by a positive number. So that is the reason I don't need to take that factor and put it in the factor table. Okay? So I can just take x minus 1, x plus 3, x plus 1. Okay. So do the factor table. X plus 3 is 0 at negative 3, negative before, positive after. X plus 1 0 at negative 1, negative before, positive after. So now get to multiply those. So negative, negative, negative is negative, negative, positive, negative, positive, negative, positive, positive is negative, and all positive is giving you positive. So what do we need? We need less than, right? We want negative intervals. So these are the negative intervals. Okay. So write it. So you get negative infinity to negative 3, negative 1 to 1, right? So it says less than or equal to, you kind of want to put square brackets, but now you need to be careful again, right? Look at the restrictions. If one of the endpoint is a restriction, you should not be taking it. So restriction here, negative 3. So I cannot take negative 3. So I have to use round bracket. The other restriction is -1. Again, I cannot take -1. I have to use round bracket, and this side is the square bracket, because 1 makes this rational expression 0. So you get 0 over something, right? So it gives you a 0, which is fine. 0 can be taken. But -1 and -3 makes the denominator 0. So a number over 0 is not acceptable. Therefore, they are not in the solution. Okay, let's do one more. Okay, so you have 2x squared plus 5x minus 3. So factor the numerator. So we get x plus 3 to x minus 1. Denominator x minus 5, x plus 2. So one side is already 0, so we did not need to move anything. Okay, now do the factor table. So look at all the zeros of numerator and denominator. So you have 1 over 2, -3, -2, 1 over 2, and 5. Okay, so put all the factors on the left. 2x minus 1, x plus 3, x minus 5, x plus 2. So do the factor table. So 2x minus 1 is 0 at 1 over 2, negative before positive after. So x plus 3 is 0 at -3, negative before, positive after -3. X minus 5, 0 at 5, negative before, positive after. X plus 2, 0 at -2, negative before, positive after that. Okay, so now what do we get? Positive, negative, positive, negative, positive. So what do we need? We want this expression to be again negative or 0, less than 0, negative or 0. So we have these intervals. So from -3 to -2, from 1 over 2 to 5. So check the restrictions, 5 and -2. So you should not be taking 5 and -2, okay? But others, like 1 over 2 can be taken, so square bracket. -3 can be taken, so square bracket.